This question is going to take quite some time. We've got, the theory is, here's the line y equals 2x, and we've also got this curve coming down here from 3, and we're going to rotate it around the y-axis here. So we're going to do this top bit here and work out what that bit gives, and we'll do the bottom bit there and work out what that gives and add them together. Crucially, the first thing we need to know is, where do they meet? Where do these things meet? So where does 3 take away root x meet the line 2x? So if I take away the 2x from both sides and then square both sides of that, so what I've got, 6 12x is there, plus 4x squared equals x. So I've got 4x squared minus 13x plus 9 equals 0. And I've just grabbed my calculator there and put the information in, and it gives me two answers. I'm not quite sure which of the x values are going to be. Is it going to be x equals 9 over 4, or is it going to be x equals 1? They're both reasonably likely from that picture there. To find out what they're going to be, let's find out what the y values are. And of course the y value, let's just put it on either side, let's do it, that one is 2, or the y value is two of those, which is 18 over 4. Now 18 over 4 is 4.5, isn't it? That's up here, off the top of the screen there, so it's not that one there. We're going for the value y equals 2. So there's our first bit sorted. We now know that this is meeting at 2, and our integral is going to be pi times the integral from 0 to 2 of, now remember it's x squared dy for the first bit, plus the integral between 2 and 3 of x squared dy for the second bit. Now moving up for more space, because now's when it gets really interesting. So we had y equals 2x, didn't we, for this first bit? So clearly this one's not too bad, because x squared is going to be y squared over 4. I'm going to put that in there in a minute. But the other one was y equals 3 minus root x. And if I want to know what x squared is here, wow, root x is 3 minus y. X is 3 minus y all squared. And so x squared is 3 minus y to the power of 4. Which you were worrying that you would have to do, but what we're going to do now is we'll do that with our binomial expansion. So we've got 3 to the power of 4 plus 4 lots of 3 to the power of 3 minus y. Then we've got 6 lots of 3 squared minus y squared. Don't want to go off the edge of the screen, so I'll keep going down here. Then we've got 4 lots of 3 lots of minus y cubed, and we're ending with minus y all to the power of 4. Wow, that makes, let's check they've got this right. That makes 81. Then I've got minus 27 times 4 is 108 y. This one here is plus, and that's just 9 times 6, so that's 54 y squared. Here I've got another minus, so minus 12 y cubed, and on the end we've got a plus y to the power of 4. Right, we've lost what we were doing. What we were doing is we were integrating that one, so integrating y squared over 4. That one goes to y cubed over 12, and we're putting in the values 0 and 2 into that, so that just makes 8/12 pi for that bit there. This bit over here, and I don't want to go wrong after a 4-minute video here, so let me pause it. There you go, I've integrated it. That was okay, just power went up by 1 divided by the new power. And now we're going to put the values 3 and 2 into that. And when you work out all of that, apparently you get 1/5 pi. The total is that bit from the top, and that bit from the bottom, and that bit for the top. That makes a grand total of 13/15 pi. Longest video I've done today.